All right, so I kind of wanted to start this out by actually going back to basics a little bit and discussing the difference between film and digital. If we boil it all the way down to its very base, the biggest difference between film and digital cameras is how the images are recorded. If we were to take a camera, let's say a Pentax K1000 or a Canon AE1 program, one of the best-selling cameras of all time, it's an old film camera made from the 80s. If we were to take that camera, pick it up, the majority of you would have no problem knowing exactly what to do because they feel the same. You're going to look through the viewfinder, you're going to rest your finger on the shutter release, you're going to focus, you're going to release the shutter and take a picture. Okay? So a lot of the mechanics and the physical structure of the camera are going to actually be very similar. The primary difference between a camera built in 1970 whatever and a camera built in 2020 is going to be how the image is recorded. Okay? Film cameras would use a light sensitive film recorded on what was called emulsion. If you remember back to that video we watched at the beginning of term 1, they used a bunch of different methods, but all of them were similar in that they would respond to light coming through the lens and recording data or values onto the chemical. Now today it's very similar. Light comes through the lens in the same way. It hits the back of the sensor now as opposed to using film, and it records that image. Okay? So the primary difference between film and digital is how we record the image. Film uses film. Digital uses a digital sensor. Okay? Now inside a digital sensor, it records different color values across 3 channel values. You'll have red, green, and blue. Okay, so RGB are the values that we record. So if whatever value of red there is, if it's crimson or scarlet or garnet or whatever different hue inside that value of red, it's going to be recorded by that red channel. If it's green, whether it's emerald or camo green or grass or whatever, right? It's going to be recorded under the G, under the green value. If it's blue, whether it's sky blue or navy blue or whatever other blues there are, they're all going to fall under the blue channel. Okay, so these they're made up of squares. Okay, and it goes R, G in the middle, and then B over on the left or right, whatever, doesn't really matter. Okay, but each one of those little guys capturing red, green, and blue is a pixel. Okay, so inside of that RGB is 1 pixel. Okay, so when we're talking about megapixels, the order of magnitude associated with the word mega is in reference to million. Okay, so if we have a 16 megapixel camera, that means that we have 16 million of these RGB things going across your sensor, up, down, left, right, all the way to the corners, that are responsible for capturing your image. Okay? So where megapixels matter is in their actual size. So if we have a camera like my iPhone, which is like a 12 megapixel camera, right? That sensor is about the size of an eraser on a pencil. It's very small, okay? The camera that I'm making this video with is what's called a full frame sensor. It's 35 millimeters from corner to corner, making up the sensor that's recording the image. I hope that made sense, okay? So let's pretend that they were the same, that they were both 15 megapixel cameras, which they're not. One's higher, one's lower. The image that's going to come out of your full frame camera, okay, is going to be significantly better than the image that's going to come out of your iPhone camera. The reason why is, though all things being equal in the megapixel scale, right, they're both 15 million pixels capturing the image, okay? the actual pixel size on the Canon is going to be larger. Each individual pixel will be larger, okay? So why that matters is because it gives us a greater value of what is called dynamic range. Now I got a great definition of dynamic range I want to look up really quick. And it is the ratio of the largest to the smallest intensity of light that can be reliably recorded, okay? So let me take a step off real quick, okay? And just look at this gray background, okay? It's pretty uniformly gray, right? But the values of the upper left hand of your screen now are significantly lighter, and I would say maybe a little bit more brighter, more yellow, at least to my eyes in front of me, than they are in the bottom right. Okay, do you see what I'm talking about? There's more light, just based on where I position the light here to record this, in the upper left than there is in the bottom right. Okay, and the reason that you can see the transition from light to dark so effectively is because this camera has a very large sensor that it's recording with. Okay? You may notice when you take a video at night that your camera on your phone, or take a picture at night, it ends up looking kind of blocky and pixelated. So what they're doing is they're assigning more pixels together to create one pixel, right? So that's where we get the term noise, when we can't see the definition between the outline of your subject, okay? And that happens when we use small censored cameras. Okay, I hope this is kind of making sense. If you have questions, obviously, let me know. So back to dynamic range. Right. So when you have larger pixels responsible for recording the data, you get a better dynamic range, which means that you get a smoother transition from lights to darks, especially in the same color scale like this gray backdrop is. Okay. So this is where having a larger sensor makes more sense and is of more value to you, is when you're doing something that has a high dynamic range. Now if you're just doing snaps, like just taking a picture of yourself or whatever, or actually putting it on Snapchat or whatever, right? It doesn't really matter. No one cares, right? But when you're trying to craft an image, right, dynamic range becomes a very important thing. How well are you able to capture your lights? How well are you able to capture your dark images, okay? So this is where sort of the term that's kind of thrown around, the myth of the megapixel, comes into play. Is yes, your iPhone or your S10 or whatever it is may be a 15, 18, 20 megapixel camera, but I promise you that same camera will be outperformed by a 15 megapixel camera with a larger sensor that's 20 years old. Just by virtue of the fact that the actual size of the pixels that are recording the image are much larger. Okay? So hang on to the end of this video. I'm going to have a couple of little images that I'm going to pop up. Cut. All right, so I hope the majority of that made sense, the difference between film and digital, and how the images are recorded, and then a little bit on actual sensor sizes and pixels. There will be a quiz just at the bottom of this page on Canvas, so pop down there and knock that out real quick. And we're going to hit this again the next time we meet. That'll be Wednesday for my A days, Thursdays for my B days. Hope you're all doing well, and I will see you soon, or maybe never.